This is the 35th video supplement for CIS 351, Grand Valley State University's course on Computer Organization and Assembly Language. This video discusses the MUnit testing framework and also shows some techniques for debugging your assembly code using Mars. I'll be using a tool called MUnit to test your assembly code. MUnit is like JUnit, except it tests MIPS assembly instead of Java. If you want to run MUnit on your own machine, you can download MUnit from this website. Just follow the download link. Like JUnit, MUnit is a unit testing framework. This means that your code has to be organized into units. In assembly, these units are functions. There will be an entire video on functions and how they're implemented in hardware. But to get started with MUnit, you only need to know a few things. So let's write and test a function. The first thing you need to know is that in MIPS assembly, functions are identified by labels, which is just a name followed by a colon. I'm going to create and test a function called sum3 that just returns the sum of the three parameters. So I start by creating the label, and then for MUnit to see this function, I need to list it in the global directive. In general, labels are only visible within the file that contains them. So in order for the sum3 function to be visible outside this file, like to the MUnit framework, I have to mark it as global using this global directive. As we discussed in the last video, function parameters are stored in the A registers. Remember, this isn't a physical property of the MIPS CPU, but rather a convention followed by programmers so that it's easier to know how to correctly call functions written by others. MUnit follows this convention and puts the parameters in the A registers, so that's where we have to look for them here. Now remember, we can only add two numbers at a time, so the first step is to add the values in A0 and A1 together and put the result in a temporary register. And now I can add the third parameter to this temporary register. The result of this add is the value I want to return, so I'll put that value in V0 because by convention, V0 is where programmers look for a function's return value. Now to exit the function, I use the line JRRA. JR stands for jump register. This instruction causes the program to jump back to the line of code that called the function. We'll see more details about this in the video on functions, but for now you can just treat this as a little bit of magic. One of those things you just have to type in to make MUnit work. The unit tests themselves look like this. In the first test, the call to the run method follows the MIPS convention and places the values 1, 2, and 3 into registers A0, A1, and A2 respectively. It then tells Mars to simulate the code beginning with the line marked by the label sum3. When the simulator hits the JR instruction for this function, the simulation ends and returns control to MUnit. At this point, MUnit executes the get method, which retrieves the value that the function left in V0. And then we can use the standard JUnit assert system to verify that V0 contains the expected value. Now let's see how to run the MUnit tests. For this example, I'm going to assume that your code is in the default package and that your Java file, assembly file, and munit.jar are all in the same directory. Using the default package and then keeping your source code with your jar files is a little bit sloppy by professional Java standards, but it should be okay for testing small assembly programs like we're doing here. You can of course use a more formal organization with your own assignments if you prefer. So the first step is to compile the Java file. To do that, you run javac and add munit.jar to the class path. Running javac should produce a class file that you see right here. Once you have this class file, you can run the tests. You just have to execute the MUnit jar file with the name of the assembly file and the name of the class file on the command line. Again, let me emphasize, you're putting the name of the class file into the command line, not just the name of the class. And if there are no bugs, then MUnit will tell you that all the tests pass. But what happens if there's a bug in the code? So let's switch back over to Mars, and let's say there was a small typo in our program. Let's say we put A0 instead of T0 here. Now, when we run MUnit, we'll see that it reports some failures. So there are two tests here, and they both, of course, failed, and it shows you what the expected result was, 6, and what we really got for both of the tests where the answer was wrong. So let's say you had a failing MUnit test that you couldn't figure out just by tracing through the code mentally. How can we dig into that assembly code and get a closer look at it? Well, just as with higher level languages, you probably want to set a breakpoint and step through the code. So that means running the code here in Mars. The challenge is that MUnit executes only the function you're testing. So when you step back over to Mars, you want a way to run only that code that you're working on at the moment. And that means you need to mimic what MUnit's doing by putting values in the A registers and then calling the function. So here's how we can do that. To specify the function parameters, we just need to add a couple lines of assembly to initialize those registers. So I can do something like add I, A0, 0, and our test initialized A0 to 1, and A1 to 2, and A2 to 3. Now we just need to call the function we're testing. And the instruction to do that is JAL. It stands for jump and link. Again, this is a discussion for an entire video, but if you just copy these steps here, it'll help you test your code until we get to that point. So now I can save it and assemble it, and we can step through one line at a time. So you'll see here the first thing that's happening is that the A registers are getting set up with those parameter values of 1, 2, and 3. And then the jump and link line runs to call the function. And we have the first line of code that's adding A0 and A1. So if we look over here to the right, we expect 1 plus 2 equals 3 into T0. And then we run that next line, and we're expecting to add 3 plus A2, which should produce 6. But we see here that it only produces 4. So now we know that that problem was line 13 right here. And when I look more closely at line 13, there I see the bug we introduced. I'm using register A0 instead of T0. So then I could go back and fix the bug. And now if I go back to MUnit and rerun the test, I should see that they pass again. So just for point of clarification, if you change the assembly code, you can rerun the MUnit tests immediately. But if you change the MUnit tests themselves, like if I decide I want to add a third test, now if I want to run this test, because it's in the Java code, not the assembly code, I do need to rerun the compiler. And now I can run MUnit again, and I see that I have now 3 passing tests. I do want to mention one other thing, a common source for confusion. Now this worked just fine stepping through the code one line at a time, because when I got my answer, when I found that line of code that wasn't working, I stopped stepping through the code. But let me show you what happens if I, instead of stepping one line at a time, just ran the code straight through. It seems to be in an infinite loop. Well, let's see what's happening. Let me now step through this code one line at a time. So we can see we're setting up the parameters, and then we call that jump and link, which executes the function. And then I'm stepping through the function. Now I'm ready to return from the function. And what does a return statement do? It goes back to the line of code right after the function that was called. Well, that happens to be the first line of the function I was testing. And it will just keep going and then return again and keep going and return again. I am, in fact, in an infinite loop because that jump register keeps going back to that return value, and then I enter the function not through the function call instruction JAL, but just by plowing ahead right into it. And that, of course, doesn't follow the conventional setup for a function, so you get strange behavior like this infinite loop. Let me show you a related problem. Let's say I didn't call jump and link. Let's say I just set up A0, A1, A2, and then without using the function call instruction, let the code just naturally fall through into sum3. Something slightly different happens. So here we are setting up A0, A1, A2. I move into the function just because it happens to be the next line of code. Now when I hit that jump register instruction, I get an error. Down here at the bottom, it says invalid program counter value 0000. So what happened is I executed a jump register instruction, but the value in that register wasn't the address of a line of code, and that caused a runtime error. So that's another thing that could happen if you're running code and you don't quite have your setup or your harness working right. Now, this really isn't a big deal. You're just doing some debugging after all. But I have enough students who get confused when they see this and think there's something wrong. And in some sense there is, of course, because it's an error. But it's just because you're running the code farther than you need to answer your debugging question. Now notice that in both of these cases, although you had an infinite loop or you had a runtime error, that wasn't an indication of a problem in your code. That was just part of your debugging technique. You still were able to step through the lines of code and would have been able to see the source of that bug. So don't worry too much about it. Just wanted you to know what's happening if you do run across that. So as I've said before, we've barely scratched the surface of assembly language, and there's certainly a lot more powerful things that can be done with MUnit and a lot more clever techniques that can be used for debugging. But this should be enough to get you started with your first couple of assignments. Certainly if you run into any situations that weren't covered here, let me know so we can talk about those in class.